Oh, hey there, mathematicians. It's Justin again. I'm on a quick break before my next volunteer assignment at the festival. And I was just thinking, we learned that the same rules for adding and subtracting integers also apply to adding and subtracting positive and negative decimals. But what about fractions? Do the same rules still apply? Or do fractions follow their own secret set of math laws? Let's investigate. When adding integers or decimals with the same sign, like negative 1/10 plus negative 1/10, we ignore the signs, add the values as positives, and then apply the appropriate sign to the answer. When adding values with different signs, like negative 1 5/10 plus 4/10, we find the difference between the positive and negative groups. So we identify the amount in each group, ignore the signs, and subtract the smaller group from the larger group. Then apply the sign of the larger group to the answer. What do you think? Will these rules also apply to fractions? Since decimals are part of a whole, they represent the values between integers. For example, the decimal negative 5/10 is between 0 and negative 1. We know fractions also represent part of a whole, so negative 5/10 can also be written as the equivalent fraction negative 5/10. Decimals and fractions are just different ways of representing the same values, so the rules for adding and subtracting positives and negatives should still apply. But we should still try some examples to confirm our prediction. You already know the strategies you need to tackle these problems on your own. Decide how you want to practice adding and subtracting positive and negative fractions. Option 1, feeling confident? Pause the video and try examples 1 through 4 on your own. Apply the same rules we used for integers and decimals to add and subtract positive and negative fractions. Then watch the rest of the video to check your work. Or option 2, if you'd like to see some examples first, keep the video playing and we'll work through the examples together. All right, let's try those example problems. Our first example is to find the sum of negative 3/8 and negative 1/8. Where do we start? Yes, anytime we add or subtract fractions, we should start by checking for a common denominator. Both fractions already have the denominator of 8, which means that we can just start adding. Now, we're going to apply the same strategy we used with integers and decimals. How did we add integers and decimals with the same signs? Yeah, we ignore the signs, add the values as if they're positive, and since we're working with fractions, we can also check whether our answer can be simplified. And finally, apply the appropriate sign to the answer. Pause the video here to finish finding the sum. First, ignore the signs. So we're finding 3/8 plus 1/8. Just add the numerators 3 plus 1, which is 4, so the sum is 4/8. Can we simplify the answer? Yes, the greatest common factor of 4 and 8 is 4. So divide the numerator and the denominator by 4 to simplify this to 1/2. Are we finished? Almost. Now it's time to address the sign of our answer. Since we combined negatives, our answer has to be negative. So the sum is negative 1/2. Let's check our work with a model. Negative 3/8 plus negative 1/8 equals negative 4/8, which is equivalent to negative 1/2. Awesome, same answer. So the same rules work when adding fractions with the same sign, but what about when the fractions have different signs? Let's try it out by finding the sum of negative 1/4 and 2/3. Ooh, we need to find a common denominator here. The least common multiple of 3 and 4 is 12. So we can multiply the numerator and denominator in the first fraction by 3, making it negative 3/12, and the numerator and denominator in the second fraction by 4, making it 8/12. That's better. Now we can add the fractions using the same rules we used with decimals and integers. This time we're adding fractions with different signs. How do we do that again? Yeah, we need to identify the amount of positives and negatives. Then ignore the signs and subtract the smaller group from the larger group. For fractions, we simplify the answer in this step. Finally, we apply the sign of the larger group to the answer. Pause the video to finish the problem from here. First, let's identify the amount of positives and negatives we're starting with. We have 3/12 in the negative group and 8/12 in the positive group. Which group is larger? This is easy since we already found a common denominator. 8/12 is larger, so we're starting with more positives. To find the difference in the positives and negatives, we can find 8/12 minus 3/12. After subtracting, we get 5/12. Is this in simplest form? Yes. So now we need to check the sign of the answer. Since we started with more positives, our answer is positive 5/12. We can also confirm this with a model. We started with negative 1/4 plus 2/3. Then we found a common denominator, making the problem negative 3/12 plus 8/12. To find the difference in the positive and negative groups, we cancel 0 pairs. Here we can cancel negative 3/12 and positive 3/12, leaving positive 5/12, the same answer. Great job! This investigation is looking promising. Following the same rules resulted in the correct answer for adding fractions with the same and different signs. Can we use the same strategy to subtract fractions with negatives as we did to add integers and decimals? Let's see. Find negative 7/9 minus 1/3. How did we subtract integers and decimals? Yep, we changed the subtraction to addition and then just followed the steps for adding. You know how to do this. Pause the video to find the difference. After rewriting this as addition, we have negative 7/9 plus negative 1/3. Now we can follow the steps for adding. Where do we start? Yes, always check for common denominators. The LCM of 9 and 3 is 9, making our problem negative 7/9 plus negative 3/9. The signs are the same, so find the total amount of negatives by ignoring the signs and adding the values together as positives. So find 7/9 plus 3/9, which equals 10/9. Do we need to simplify? Well, since this is an improper fraction, we should change our answer to a mixed number. Dividing 10 by 9 shows that it's equivalent to 1 and 1/9. Finally, should the answer be positive or negative? Right, the answer is negative 1 and 1/9 because we combined negatives. Nice work! The same rules as subtracting integers and decimals also work for subtracting fractions because we solved the problem by changing the problem to addition. And we already proved those rules are the same. Awesome. Last example. Find negative 5/6 minus negative 1/4. Pause to give it a try. All right, check your work. First, change the subtraction to addition by adding the opposite, making this negative 5/6 plus 1/4. Now, follow the steps for adding values with different signs. The denominators are different, so find a common denominator. The LCM of 6 and 4 is 12, so we can rewrite our fractions as negative 10 twelfths plus 3 twelfths. The signs are different, and we're starting with 10 twelfths in the negative group and 3 twelfths in the positive group. Which group is larger? Right, the negatives. So to find the difference in the groups, ignore the signs and find 10 twelfths minus 3 twelfths, which is 7 twelfths. Since 7 twelfths is already simplified, we can figure out the sign of the answer. Should the answer be positive or negative? Right, the answer is negative 7 twelfths, since we started with more negatives. Nice work, mathematicians! We confirmed that the same rules apply for adding and subtracting all rational numbers: integers, decimals, and fractions. For now, finish the guided notes and practice levels 1 through 3. And until next time, keep questioning, keep calculating, and remember, the type of number may be different, but the rules for adding and subtracting stay the same. See you next time!
Hey, hey.